Okay, so we're going to start off this word problem just by taking a little look about what sort of information is given and how we can use inequalities to kind of set this up. If you haven't taken a look at the problem yet, take a quick look, try it out for yourself, and then come back to the video with your solution. Stick around here and we'll kind of go through each section, ABC, and see what you get. So let's take a read of it and see what we can do. Yvonne is planting trees for a summer job. She gets paid 10 cents per tree planted, and she wants to earn at least $20 an hour. How many trees must she plant per hour in order to achieve her goals? Okay, so she wants to get at least $20 an hour. There is these words here, at least. That should kind of clue us into something like an inequality that we're going to use for that. She can get more than $20 an hour. She can equal $20 an hour, but she wants to get up to that point. And then how many trees is she going to have to plant in order to get that goal? So let's write an inequality to model the number of trees Yvonne is going to plant to reach her goal. So let's kind of start by just kind of framing out a little a way of thinking about this problem. If she can get $20 per hour, that would be acceptable. $20 per hour, that would be acceptable. She could get anything over it, so like $21 an hour, whatever the case, 22. She can always go up and up and up with this money. So what we want to figure out is how can we express this as an inequality? And we're going to need to introduce a variable to kind of help us out. So for A, let's kind of introduce a variable. Let's say that T equals number of trees planted. Okay, so now that we have that, that's our unknown, the thing that we don't really know about this question, we can kind of build an inequality around that. She's going to be getting $0.1. I'm just going to leave the dollar sign out of it right now, per tree she plants. And if you kind of remember from our linear relations unit, when we say like per tree or anything like that, we're really talking about multiplying. So if she plants one tree, she's getting 10 cents. She's planting 2 trees, 20 cents. 3 trees, 30 cents. You can kind of think of it as making sort of a table here with, the number of trees that she would plant, 1, 2, 3, 4, and the amount of money that she would get, 0.1, 0.2, 0.3, 0.4, and onwards, okay? As we kind of work our way down through this list. That's kind of what we did with the linear relations unit, and we got our equation from that. If you'd still like to make an equation like this, be my guest, that's okay. But what you're going to see is that every time that we are kind of increasing the tree by 1, we are adding 10 cents. Every time we increase our tree by plus 1, we're going up by 0.1. And if you wanted to work your way back, you would see that, for 0 trees planted, she'd get 0 money. So this would be our equation that we're kind of looking at. Now, we want this to be at least $20 an hour. It could be more than it, but it has to be at least $20 that we want to have. So let's kind of set our inequality by saying that the amount of money that she would get, which is 0.1 times the amount of trees that she would plant, would be greater than or equal to $20. So this is kind of representing the amount of money that she's going to earn. Amount of money made. And what we could say here is we could just say per hour, since we know that 20 is going to be the minimum amount per hour that she wants to get. Minimum per hour. She wants to earn $20 an hour. So we have an inequality. We are modeling how much money that she would make per tree, and this wants to be greater than or equal to $20. So write an inequality to model the number of trees that Yvonne wants to plant to reach her goal. So we've done that. We've modeled this inequality. We haven't solved it yet, but we've modeled it, okay? Now, B is kind of thinking about a little... You kind of want to go behind the scenes here and say, okay, well, what does it kind of mean in terms of this sort of aspect of it? It's a word problem. It's supposed to be like a real life problem. So would it make sense to use something like the whole numbers, which if you remember from our course notes, and we talked about it from a while ago, but whole numbers are things like 0, 1, 2, 3, ... and it keeps on going like that, and they're whole numbers and they're positive. Integers, on the other hand, integers are still these types of whole numbers, but they also include negatives as well. So 0, plus or minus 1, plus or minus 2, plus or minus 3, dot, 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 keeps on going. If we are talking about the number of trees that she's going to plant, then we really don't want to be talking about integers here, and we want to talk about whole numbers. Whole numbers because we're only going to be able to plant positive 1, positive 2, positive 3, and so forth trees. We're not going to be able to plant like 1.5 or anything like that either. So whole numbers would be something that we are wanting to take into account. Okay, so let's keep on going from this. We're going to do whole numbers, and now we get to take a look at actually solving this inequality. So we have 0.1 t is going to be greater than or equal to 20. This 0.1 t, we are multiplying t by it. So the way that we get around isolating for t is by doing the inverse operation. So we're going to divide by 0.1 instead. That's going to reduce out. Now we're dividing by a positive number, so we don't have to take into account that we have to flip the inequality sign. But what it does mean is that she needs to plant minimum or at least 200 trees. She needs to plant 200 trees. I think I can do a little better than that. 200 trees per hour. Per hour or more in order to make $20 an hour. Or let's say in order to make at least $20 an hour. Of course, if she plants more than 200, then she'll get more than $20 an hour. But that's really what the question's looking at. Can we make an inequality? Yes, we've introduced a variable for that, very important part. We've kind of recognized that we're not going to be able to have, negative numbers for that. That wouldn't make sense. Nor would it ever make sense to have like decimal answers as well. So when we're going to solve the inequality, we would solve it like normal, like this. But again, we want to make sure that we have whole numbers, right? We want to make sure that we have whole numbers as well here. And that she needs to plant at least 200 per hour or more in order to make $20 an hour.